But India can also do this where you make it locally but sell globally.
Still, India is still lagging.
Is that the best technology out there in the world?
Whatever the patent being done for that application, for that particular performance, multiple parameters will be there where it is struck for them.
So what led you to your determination in this one single component over such a long time?
Down the value chain, also they should have the advantage of it.
Like, why is this distinction in India between blue collar and white collar?
They work for every cost.
So what all machines are required in developing an electric motor?
If I buy a ICE engine, I will be polluting all through its life.
So how ITIs in India are performing as according to you?
It needs to be decentralized.
And we can't expect, or we shouldn't expect actually, for the companies to have their in-house service centers spread across the country.
Magnets lose the magnetism after one level of time.
Great. So, hi Murali, welcome to the podcast. So, let's start with what is DriveCore.
See, DriveCore as a company, we are focusing on electric motor manufacturing.
Okay.
And also smart controller development and manufacturing. This is the overall view of what we have wanted to do in DriveCore.
Okay.
Why we are doing it is the main important thing here. We know that we have rare earth magnet issues are there all over the world, and it is getting choked nowadays because of the geopolitical issues.
Right.
So what we are focusing right now is not to use rare earth magnets and use rare earth free or magnetless motors basically.
Okay.
And design, development, manufacturing, complete smart powertrain system as a whole.
Okay.
So this was planned last 2 years before we initiated this as an idea.
Understood.
Yeah, with my colleague Sudipto, and later on slowly we got into this, and last 1 year we started working on this topic. Yeah.
Understood. So what stage you are at? Like, have you developed the technology, or like is the R&D done and you are now looking at prototyping and manufacturing, or you are just you are also parallelly also working on finding the solution and doing the R&D in parallel?
So right now we already developed one motor with a most common configuration and power requirement for the industrial condition right now, EV market as of today.
Okay.
And we developed that motor already. The design development is being done. Now we are doing the prototyping stage right now. We already started prototyping. We're expecting to get this prototype by next 1.5 months to 2 months in hand.
Understood.
So that we can do the testing and then further talk to our customers as well.
Okay.
And see the opportunities to work with them.
So this is the rare earth free motor, or is it the usual motor?
It is a rare earth free magnet based motor. We can call it as permanent magnet assist synchronous reluctance motor.
Yeah, understood. Yeah, we'll come to the details as we go along the podcast. Yeah. So, but do you have a manufacturing facility or some facility where you build, or you're doing contract manufacturing or so forth?
Right now, we don't have the manufacturing side of that because we just started up now. It's just 6 months old company. What we say is we are active on that, I can tell.
Yeah,
okay.
Yeah.
So we are looking for manufacturing anyway for the motor because it should be under our control, the complete quality.
Yeah.
We will also see the opportunities of contract manufacturing as well based upon the capabilities of the contract manufacturing in future. But right now, our focus is more of designing and development of the right motor to the right fit of the market. This is the first.
Right. So are you then, for the prototyping and for the initial phase till you have your own manufacturing facility, are you then going to outsource the parts from different vendors to kind of build the stator, rotor, and all sort of the winding and everything?
Yes, you're right. That's correct, because as of today's condition, need supplier support as well individually for each and every component like stator, rotor, magnets, a shaft, for example. We will be working with them and get these components ready, and then we will be assembling in our own manufacturing workshop initially. Then slowly we will be building up into the plant later stages. Intention of making ourselves is to have a complete control over the quality and delivery.
Understood. And are these vendors or these partners kind of in the Chennai region, or from where are you sourcing it? Where are they geographically located majorly?
It's all over India, it's there as of now. But today's condition, as a prototype, Chennai is good enough to make this as of today.
Okay.
But as we grow into manufacturing level, then we need to have whole of India, we need to find it so that cost dynamics will come into picture there.
Right, right. But like for example, you are now developing this rare earth free electric motor. You have the concept and you are now prototyping and then going to fabrication and so forth. So why haven't been there Indian manufacturers for this already till now? Because this has been a long problem, long back, like a decades long problem. So why haven't Indian manufacturers already been doing this?
I can say Indian manufacturers started doing this maybe few years before.
Okay.
At the time of pandemic, when we blocked China, other side, the imports are being blocked. And after that, again, the choking of rare earth magnets have been the issue. So Indian manufacturers started that. It is not like they didn't start. But yeah, there's a very limited delivery is there right today. Few companies are doing it.
Right.
They may be manufacturing a bit, but not so mass manufacturing level. They have a business as well as of today. Still maybe companies as the current condition is maybe if the choking is not there, OEMs will go back to the original rare earth magnets as well. But the problem will always there. We don't know when the choking will come. So because of the geopolitics. So it is better to have this backup as a ready for every OEM should take this as a consideration.
Understood.
We feel, and it is important for us.
Understood. But is your final product selling price going to be less or more than these rare earth alternatives?
It will be less for sure, because basic important cost would be magnets cost, where the neodymium iron ore on the rare earth magnets, right, been changed to maybe what we can say we are replacing with ferrite magnets. So the cost will be less in terms of magnets, and also of course manufacturing level the cost will be similar itself between both.
Yeah.
Controller also almost will be the same.
Okay.
So the delta would be more of the magnet costing. So there will be lesser cost. Yeah.
Understood.
Which may again we need to pass it on some portion to customer as well. Yeah. That need to be, because they are also taking that advantage out of it.
Right.
So
right. So are you right now you are developing for EVs, right? For EV companies. So what's your future milestones? For example, are you going to also looking at expanding it into aerospace or robotics or so forth? What are your plans going forward?
Yeah. See, my experience is all through motors itself. Last 22 years right now, I'm into motors. So my intention is not just to start, just to start with EVs. So then we thought of this DriveCore together with Sudipto. Then we started with this work. But we added up, we are having a plan. For example, for thing is motor level technologies we need to grow. Today we are in PMSM, synchronous reluctance motor.
Okay.
PMSM would be one of the next levels. Already it is in industry as well. Anyway, we should have that motor anyway.
Yeah.
Then axial flux motor would be the next level in our product pipeline and technology pipeline. Then synchronous reluctance motors is one more is there, which is the final destination where we don't have even any magnets are there.
Okay.
So this is our pipeline for technology development.
Right.
And as you asked for the what we say for the application oriented, right? So EVs are the first today. So there is no question about it, because there is an important condition today in India. Yeah. But our intention is to go to even drones are the good opportunities, which we are looking from our side as very good opportunities.
Okay.
After drones, also in drones only we have multiple agricultural drones are there. So multiple applications. So I think that market will be fit for us. In fact, once we get into that. That can be one of the parallel vertical we are thinking of.
Understood. So since you mentioned, so can you share some backstory about yourself and how you met Sudipto and how you guys thought that, okay, we should do this and
Yeah. About me, I have been into from 2003 after completing my MTech from Jadavpur University, Kolkata. I joined Crompton Greaves. After there, I got this interaction with the motors first time. Then started interacting with BLDC after that. Started with, then worked in Samhyun, South Korea. I was there for a year there. Came back to India, and EVs were just started there. First phase of EVs were just started there. So I was the part of that EVs that time. I was working in Electrics Motors Limited, which is Luminous Power Technologies company. And I was also into Ampere vehicles. Then Mahindra Electric. At that time, it's Mahindra Reva. Then after that, gone back to China. I was working in China for 5 years. So where I got very good exposure towards the manufacturing side of that motors basically, because you know how like mature they are in terms of manufacturing. After coming back, I came back and started working again in a few of companies. Last company was Royal Enfield, which I just left from Royal Enfield to continue to do my own work right now, my projects. 2 years back, where I was discussing with Sudipto, we got in touch somehow in some of the conferences. Similar passions. He is into automobile sector. I am into EV sector. But he is more into execution level. I am into technical level. So I think we both matched each other mostly. We were thinking 1 year we were just talking what to do. We don't know, but we were in touch every day what to do. Then after 1 year, maybe 1 year back, like February 2025, we started DriveCore. Though I was not active, I was totally into other company that time, so I couldn't be active. 4 months back, I just started being active, and then almost like we are very busy now in almost every day in various activities.
Understood. So the R&D that happened from February 2025 till this year, or you started in last 4 months?
Last 4 months is the most R&Ds, because setting up the company and setting up this website designing, those all administrative works we've been done for last month, almost like first 6 months of the time. But we were also talking parallelly with what we say stakeholders to understanding the motors and all. I was not active. My team was active and they were doing this all because I was with others.
Understood. So do you have a R&D team as well, like who is working with you to?
Yeah, we have a R&D team. Like we have a mechanical engineering, one senior engineer level, and electrical engineering also, and prototyping team as well, and even electronics team as well I have. But those are like core team as of today. So sooner or later we need to go down the line, then next level team.
Understood. So you were at Shenzhen, as you mentioned, for quite a long time. So can you tell me more about your experience over there, how Shenzhen or China at a broader level is different as compared to India? And because there are both sides of the story, you will find extremely high quality manufacturers. At the same time, you will also get cheap quality manufacturers, and you have to maintain the quality standards. You have to have your own third party quality inspection so that you make sure that your vendor is not kind of replacing your material with some other thing. So can you elaborate of how that ecosystem works and what led you to particularly spend so much time over there?
See, it's a very interesting philosophy what I learned there. Okay, we have been listening from almost like 20 years maybe while we are studying, and the Chinese products are cheaper products. That is what we have been into that, right? But only when I went into China, worked with them, then only I understood how they actually work. They work for every cost. How much money you pay, you will get the product like that. That is the main thing what I learned. So they sell even to US, Europe as well with their own standards. So there is no question about quality with them at all. Why we are getting this, we have to introspect from our side as well. That is very important thing. So nothing is free basically, right? So that is how they work. And they have the main interesting thing what I liked when I was there in 2014, I was there. At that moment, we can see a lot of electric bikes were there on the roads. You can find you don't feel any find any petrol bikes at all. So that is how in 2004 time. And
2004 or
14 time. Sorry, 2014 time. 2008 onwards, I was started traveling there. So I was traveling also. So at that time also it was there. So it's growing as the time I went to 2014, right? So then I can see slowly cars being increased, electric cars being increased. At that time BYD was there. So what the way they do is they build complete ecosystem of the EVs around. There are repair shops every around the corner for the EVs. Here you don't find today. That is what one important point I always give in my LinkedIn posts as well, importance of ecosystem, right? So that is how it is. And they also have advantage of mass manufacturing, what we say unit scale, unit economics, right? All the hub motors, if I see, there are different kinds of sizes, right? For a 10-inch to 18-inch sizes they have. They all have complete rim level tools and all are very standard tools there with them. So every entrepreneur can just buy the tool, build their lamination, build their things, build their lamination, build their covers, build their rim, and then they can do that. What the advantage here is cost advantage coming up. So that kind of scale, still India should get into. Today's condition, we are still not ready. If at all I wanted to make motor right now, even tooling for the motor, I need to go for China itself. No other way. Yeah, there are doing some. I'm not denying like people are doing it today. But yes, the quality of the tool will be different. The life of the tool will be different for lamination, for anything. So those things should improve. You should not deny the work developments happening in India. It is happening. But still, they are ahead on that point.
Understood. So 2 questions. One is like, why haven't Indian manufacturers be able to do that? Like I was discussing with someone a while back that, for example, China also, though there is a good demand within China of these components, but India can also do this where you make it locally but sell globally. So you have the global market.
Yes.
So that comes to the second related question where, because even in China, I don't expect that, because like you need experienced welders or you need experienced machine operators, etc. I'm not like, it feels difficult to imagine think that their salaries will be like penny worth. I mean, you can tell better, but what I'm trying to say is that I feel that just cheap labor cannot be the reason behind China being able to become such a large global supplier. So why can't that happen in India, where we have an equally similarly cheap labor in that manner? But other than that, what exactly are we missing over here?
Yeah, it's like what I can say is a chicken and egg story. What I can tell, it's a simple, like, there they have a demand in China, and for the demand there are policies as well being supported by government as well, so that the entrepreneurs can invest on the businesses at each and every level of the value system.
Okay.
Here for us, what happening is, yes, government is giving this right now. Last 10 years we are talking about this.
Yeah.
That is more of on the product level, like EV level. Okay. So sales level, we are having much more sanction and advantages for there. But if you go down the value chain, still there is no, like PLI has come just now, and it may help a bit, but it will take some time. So maybe we should have similar kind of like what we say, government policies, I can tell. So similar kind of government policies down the line, full value system should get helped actually.
Understood.
That's what missing is what I feel.
So you are saying that maybe we have enough funding right now through ANRF or RDI fund and all that amount, the government that is spending right now for the last few years. But that is like, for example, going to deep tech companies, which is great. But you also need a level of funding that are going to be the vendors of those deep tech companies. The upstream supply chain, where you need precision components, you need good machine shops, you need a good such similar.
That is the point what I mean. Down the value chain also they should have the advantage of it. Otherwise the cost advantage is not coming to down the value chain, and advantage is only in the top level, then it is not value distributed properly. So then the motivation to do this business will be lost.
But is there a possibility, like for example, because government is funding so much right now in a few deep tech companies, so is it like, are they looking at that whole company will make their own end-to-end will maintain their own end-to-end supply chain altogether?
Not be, then that will be inefficient completely. So the OEMs should not be involved in every value chain, then it will not be useful. So for example, some nowadays, if you see Ola is there, also Simple Energy, so they are started doing their own motor manufacturing as well, and Ola is doing battery manufacturing as well. So that is there strategically, that they know the reason why is like they wanted to be at least risk when there is some problem happens globally, they can supply their own bikes. That is valid point. But they cannot go beyond that below bottom line. So there are multiple, like, even though motor manufacturing is happening, they cannot go in starter level and they cannot do it. As of today's market conditions, investing on a starter lamination tool or investing on a lamination machine will be like crores of money. So cannot. So that will not be, that is not expectation at all, and cannot be. So that is not valuable.
But are there few manufacturers who are doing that? Because I mean, that's where from you will be supplying your prototype material and so forth. Do we have any similar facilities in it?
There are actually in India right now. Motors, if I say about motor, battery side, yes, there is value chain is still not ready. They still need to be improved. As of now, cells has to be impedant also. For motor side, I can tell most of the motor components can be done in India. So
Okay.
there is no any problem in that as a whole, because companies like Crompton Greaves, they already set up complete ecosystem all over India initially,
Right.
from 50, 60 years down the line.
Right.
Later on, recently, like Atomberg has come, which has made much more very good opportunities to many more vendors. There is no any technically there is no problem. We can do it, but problem will be the next level investment of tooling, which will be unique to unique product for every unique product. Then the cost, time, managing the projects will be specific team should be there. So additional costs will come in that way. Or there can be some commonized designs if there are something like that, then the cost will be advantage. But generally that can't happen in India because every company should have their own design.
Understood. So again, one question I want to elaborate on that a bit more. Like, why China is able to develop so high quality for so cheap? I mean, other than the like, what is the exact reason why the price is also low and the quality is also high?
The price is low. I already told you. They will have a commonized tools. Even tools will have its own market.
Okay.
Where I, as an entrepreneur, I can buy that tool. That tool will be having what we say mass producer kind of tool, where they can be lesser cost. Input of the complete production itself getting less.
Understood.
So that will help in any way. It's a mass manufacturing I'm talking.
Understood. Okay. So you mean that there is already a market for even the components or the tool level, and this whole costing is low because of the business aspects of the enterprise, not the technical aspect, or not just that okay, this machine is going to cost this much or the raw material is so this much. It's just that they are able to mass manufacture, and that brings down the per unit cost to very low.
Right, exactly. For example, I can tell you an example, like there are 5 EV companies are there, e-bike companies. Okay.
Right.
5 e-bike companies will have motor side covers, I will tell. Both there are one side cover here, one more side cover here, right? Both are covers.
Okay.
So those covers are standard with some small changes in that. So there will be some inserts will be there in the same tool. That same supplier will make to all these 5 people. So see the mass number how they are making it.
Right.
That is the advantage what I feel, because as I saw them very near when I was there, right? That's what I can say. That is one question what I answered you. Second question is quality. Quality, that is a very, very important thing. Skill levels are to be improved in India. Skill still, India is still lagging.
Okay.
No doubt in telling that people, we have to accept what we are lagging. And right now things are moving. A lot of skill management companies are coming right now, and they are started training people also. But it is coming in EV level. Still we need to go down the line also. I can tell you one example. In China, one person who just earned some 3,000 RMB per month, she does the winding, the manual winding of the hub motor within 5 to 10 minutes, which I tried. I couldn't do within half an hour also.
Okay.
For me, it's different. Okay. Even our working people cannot do. That is how it is. Right. So the skill level is important. And another thing is, if today that person is not there, they have a replacement for that also. So for us, that is another problem. We will not have a replacement. Today that person is not there means we are out. Or if that person left for other job, we are completely blocked. So that kind of pool is there with them. That is what I can say. These two are the critical things.
So is that pool in China developed by the public machinery? Like, for example, in India, there are ITIs and advanced training institutes. So how would you compare the two in China versus India, and how China has been able to develop such a skilled labor out of their public infrastructure?
To be frank, I didn't get in so much detail in their side education system. It's not easy to understand this. But yes, they have dedicated training centers that comes up along with, like, as the student level only, they will get these all vocational trainings. That's what my understanding is, as per my discussion with the people. And then after that, they will choose their interests.
Understood. So how ITIs in India are performing as according to you?
It needs to be improved, I think so, because ITIs in India was mostly focused in basic electrical level and mechanical level things till maybe 10 years back. Maybe now they are improving. For sure, there is a change. Moreover, I'm talking to many skill development companies nowadays. People really wanted to upskill people. So we have seen the market in that particular scenario as well, like what we say, skill development as well. So I'm seeing there is a positive hope there in terms of that one.
Right.
but it needs time to grow as a complete system.
Understood. So I would ask this question, like if we compare to Germany, and like why is this distinction in India between blue collar and white collar? Like I'm sure no white collar engineer would know as good as a blue collar welder to how to weld a particular joint and how different materials to use or operate the machinery as well. So why is this distinction, and why our university ecosystem and engineers are not learning those jobs?
There is the miss point. Agreed. There is where the like our education system is like that itself right now. There is no any hands-on experience coming up, even though we do engineering. Same is with our case also. It's nothing great. Okay, but what we did after joining in our companies, we started learning. But now that is where now the change I can see, the skill developments, and also like institutions really seeing, like for example, I am going around institutes recently for incubation, meeting them and all, right? So you can see that they are already setting up the complete ecosystem themselves. That I really liked that. They're investing money on that. So they know now the students who will go out of their university, they need to have some basic skills before they go.
Right.
So that appreciation is there. That is what I feel. The positive thing, the difference between blue collar and white collar, yes, there is still there because of this condition. Okay, maybe what the better way is, even the working level people, the welding people, they also need to get upgrades to the next levels in terms of training. Absolutely. That may need some different ecosystem to build in terms of mindset of the companies as well. Right. That will help the complete ecosystem to grow on that. My thinking is that,
Absolutely. Let's talk about hairpin technology of the winding in the motors. So firstly, is that the best technology out there in the world for motors to get maximum torque, or are there better technologies as well?
There are better technologies. It's not like only hairpin is one of the way,
Okay.
It is basically, it's a change of the process.
Okay.
So right now we are using the round copper winding will be done. Hairpins will be inserted into the stator teeth, and then it will be welded. So it is a process change. So the advantage would be utilization of the copper there. That is the only advantage. Means you will have a little better delta than existing. So it is like there are multiple other technologies are there. Actually, if you go completely change out axial flux, you will have a better power density.
Right.
You completely go to SRM, switch reluctance motor, then you will get rid of complete magnets at all. Like simple process will be there, but they have its own problems. So all will have the plus and minuses for everything. We need to have the proper point to decide it. Which one we want.
Understood. So then the question is, like, for example, these, let's say this axial technologies or hairpin technologies or similar technologies, they have been invented somewhere. They haven't been invented in India. And those players, like, I don't know if their patents have expired or not. I mean, I feel that a lot of active patents are there in India. So how do then Indian manufacturers cope up with, because then you're not completely free to develop and manufacture those things. You have to then depend on whether the patent owner allows you to do or not, and then countries have export controls and so forth. So is that a challenge?
I don't think it's a challenge, because see, if that is the case, even PMSM synchronous reluctance motor, what we are doing, PMSM, what we are doing, which is already widespread in India. So we cannot do anything, basically. So it is not the problem, in my view.
For example, if someone has developed a hairpin technology and they have patented it in India, that doesn't stop a startup or a company to manufacture hairpin technology and sell out as in electric motors.
Yes, exactly. It can be for the different application. You can use it in a different way.
Okay.
It can be like, it's not like stringent, like for whatever the patent being done for that application, for that particular performance, multiple parameters will be there where it is struck for that. They have to prove that is working in patent level. That means that scope is that much scope only. It cannot be beyond that. Otherwise, whole of technology will be going out, right?
Yeah, understood. Exactly. So you have deeply specialized in electric motors for these decades, multiple decades.
Right.
So what led you to your determination in this one single component over such a long time?
I don't know what to tell. Even from my BTech onwards, engineering onwards, I love motors. I don't know how I was good at that, but I never thought like I will be into this completely like all through my career. But then I got opportunity in Jadavpur University where I was specialized in motors again.
Okay.
Then Even maybe I should have gone to software, but I didn't go somehow, and luckily, and now again I got Crompton Greaves job, which is again making me motors again. So then, even after that, also many of my colleagues in Crompton Greaves went back to software.
Okay.
So I stuck there for some time. I got myself stuck, I can tell. So which made me to pull on till today, because after that, what I understood is my career is unique. That's it. That is what I can see. At least I will have my own way of career. Today I'm not able to succeed. I faced a lot of problems initially also. Today's condition, if I go back, just see back and see what's happened, like,
Right.
I'm just getting the full confidence of whole career. Like, yes, all dots are connected. Whatever I am doing it. Yeah, that is all.
Right. Understood. So now, since you have this experience, so you will be the best person to answer this question. Like, why haven't we been able to develop the best motor that can ever exist in the world?
Okay. See, it is basically technology evolution, what I can tell. Okay. Initially, like what we say, 30 years back, induction motor is the only cash cow for us, right? At that time, power electronics was at the minimalist level, thyristors we were using. Slowly it became, now next level of semiconductor devices came, MOSFETs. Now we are doing SiC. Sooner or later we will be doing GaN. So power electronics also evolving. It is not only the motor as specific we are talking. As a motor, it's running means only induction motor. After that, whatever motor is there, it will have a controller as well. So it is the marriage between motor and controller together. So that is the main point here. So as we go on here, for example, initially the frequency limits also there with the switching frequency of the MOSFETs. Slowly it is also increasing right now. And also steel level of steel technology also improving. Magnets also improving. So it's like this is the main reason why we are not able to do the right one first time. It will be always will be like this. And finally, what we are doing now, we are growing up like in different levels. Power electronics is growing, magnets are growing, stator materials are growing, and magnets got a problem there now. We are again going down with the magnets. So this is how the evolution coming up. Like without magnets, we wanted to, that is where it is switched electrons motors.
So I have a few questions of basic terminologies that are being used. So if you can let me know, like, what is a drivetrain and a powertrain in this whole thing, and how do they differ? What is the difference between them?
I think both are almost mix each other. We just use replacement to each other generally. Yeah.
Okay.
If I say powertrain, it would be like motor controller.
Okay.
Motor and controller as a powertrain today.
Okay.
Plus transmission also sometimes will be added based upon the EV system what we are using. Okay. Some may use directly like a hub motor kind of thing. Then it will be just powertrain is motor and controller. If it is transmission also being used and gear system is being used, then it's a whole system as a powertrain, we will say.
Understood.
Drivetrain is the similar system. Maybe battery will be added. I'm not sure the fine line between both. We just use replacement to each other. Actually.
Understood. And what is a direct drive?
Direct drive is like the motor will be fitted directly into the vehicle wheel.
Okay.
It's a hub motor basically.
Okay.
If hub motor, the wheel has been fitted in the vehicle, in the wheel, and the wheel will be running. So the hub motor speed will not be going beyond 300 to 400 RPM. Low speed, high torque application.
Okay. But then how can a motor achieve, electric motor like for a EV can achieve high torque without a gearbox in between?
That is based upon the design of the hub motor. If you see the hub motor, they are broader one, more diameter one. Okay. And if you see the smaller, like what we say, the inner rotor motor, it will be smaller diameter, right?
Okay.
So there is a configuration difference altogether.
So is there also the difference in the BLDC design?
Yes, internal configuration will be different. More magnets are being used there.
Understood.
There will be 60 magnets, 80 magnets, like more magnets being used. So here we will have a lesser magnets, but it will be like a high speed design. Whatever in-house inner rotor motor we are doing, it will be high speed design. So there is a difference. There is a low speed design, it's high speed design. High speed as it is, we cannot use with driving. So we have to use some reducer. That is where the transmission comes.
Understood. And so in what cases the hub motors are used where this direct drive is there?
It is a simplicity, that's it. Hub motors are very simple to assemble in the vehicle and there is no complications of alignments and all. So it will be like, it's a wheel already there, so it will be directly fitted into the vehicle and connections will be done to the controller. So assembling as a vehicle will be very simplest and minimalist as compared to existing like an inner rotor motors where you should need alignment with the motor output to the wheel output, the belt, and again the belt related issues also will come. Belt or chain issues will come, and alignment and any vibration will be added up with this transmission as it goes. So those things will be lesser in hub motor.
Understood.
That is how simplicity is matters.
Understood. So you mentioned that you are also developing your own controller, and this whole system is not just that electric motor is the king, but you have to have a marriage between the controller and the motor, and both of them together makes a system win or fail. So I mean, are you developing your own proprietary software for that, the controller that you are building, and how important is the controller in the whole output, and what all optimizations go into all of that?
Yeah, I may not be able to give too much details today.
Yeah. Sure.
Because we are doing it, but we cannot keep it out. So I can tell, yes, we are developing a controller from our side. Now there is a team already. We started working.
Okay.
Right now we are into complete architectural development. We are doing later stages where development also we will do.
Right.
We are also working with one chip manufacturer. Closely to. Work together on specific chip and work with them directly.
Right.
And they also will be supporting us in hardware level and software. Yes, it is our own part, and we will be developing that in-house as per customer requirements.
Understood. So you're also then working on the electronics part of it.
Electronics part as well. Yes. Yeah.
Understood. So for example, if someone has to redesign a motor, then I see that they have to, then it can't be that, okay, I will just change this small component and things will change, things will improve or so forth. If someone has to redesign even a single component, they have to rework the entire drivetrain or powertrain for that, in that respect, right? Because then you have to optimize how the controller is operating the phases inside the BLDC and how many magnets are there. So even a small change will require you to rework the entire thing, including the electronics.
It's not like that. Generally, what happens is controller needs some of the important parameters of the motor.
Okay.
It is not like physical parameter. It's more of electromagnetic parameters like IDIQ and that kind of parameters, which are LDLQ. So those inputs should be given to the controller. Of course, number of magnets also matters because of the frequency. How much frequency it is running. So those inputs will be given to the controller, and controller will be developed according to that. Of course, the current level, voltage level, all matters.
Right.
Now, if I change something, minute changes, if I say, that may be we can just manage with the programming changes as well.
Okay.
It depends upon the magnitude of the changes, I can tell. So maybe we should not be detailed on that because that will be a huge topic as a whole.
Yeah.
So the magnitude of the change, what you're doing will impact how much impact. If you're changing the complete current level itself, then you need to redesign complete controller.
Right.
If you're not changing current limit, you're only changing some level of frequency level or that kind of level means, then controller level, software level only we can update. So we can have that kind of decisions based upon the changes.
Understood. So are there any open source softwares and open source, like for example, for 3D printers, there is an open source 3D printer which people can use and they can kind of design themselves and print it out and so forth. And there are open source in robotics, there is a lot of open source things that are there. So are there any open source powertrains or drivetrains with these MOSFETs and controllers and the BLDC design, which anyone can just do a DIY? If they have a college project or something, they can manufacture it by themselves. Do that blueprint exist in open source anywhere?
As my understanding is, as a hardware level, as you told right now, may not have. I may be wrong, but in my view, we can generally what happens is, if I am talking to one particular supplier, for example, some chip supplier, they will have this open source, whatever you're telling, right? They will have one evaluation board. So that way we can get it. So, but that will not be suitable for our application. That will be suitable for running your motor. That's it.
Right.
After that, the current level and all, you need to do your design and you should manufacture it accordingly.
Right. So I was thinking in terms of the possibility where, let's say, if someone has a particular use case, someone is in a village and they have to kind of make a small miniature EV or a robot for their farm and for their neighbor's farm. So is there enough available open source tools that they can use to kind of order things, assemble it themselves, solder it, and then kind of run it in their community?
In the today's information condition, you will have everything on web. Only thing is identifying is one. What I said is just now is a proper way with working with some chip, but that is the companies can do. But
Yeah.
what you are telling is DIY level. People are doing it. Many people are doing it. So they can find it anywhere. How they use it and how they edit it is matters. Finally, it needs to suit with the application as well.
Yeah.
So if it is not suiting with application, then you are not using the complete system efficiently.
Understood.
Right? That is
And-
how it is.
Understood. In the electric, like again, since I've been studying hairpins, so again, a similar question related to that. So in hairpins, you do a laser welding. I'm sure in other parts of the BLDC also laser welding must be used. And so how laser welding works? Do you have your facility, or will you be doing laser welding? And is that available readily in India and so forth?
Again, this is another big important question, because there are laser welding companies are there in India right now.
Okay.
There is no question about that. But again, the quality and the reliability of that. For example, there will be head there, which is actually do the laser process, right? That head is the costliest of everything.
Okay.
And again, China is the main source for it. That is how it is. The ecosystem is still pulling there only to everybody. Even though in future, if I buy a machine, maybe I can buy from India, but again, head also they will buy from somewhere, China itself or some Europe, anywhere. Maybe that level, second, I mean, what we say, the value chain of that particular machine, again, still not fully in India.
Right.
Okay.
Right. And that leads to, like, you are outsourcing or partnering with your vendors. So these vendors, what all machines they have, and are they importing those machines from China, Europe, or are we all in India also? There are manufacturers who are developing similar machines, like for example, auto winding machine and other hairpin technology, because that's a very, you need it fully automated and so forth. So for electric motor and the whole MOSFET ecosystem, the controller ecosystem, are we able to manufacture it in India, and what all machines are there?
Yes, India is ready for that. Basically, that is what now evolution is happening right now. There are many companies in Bangalore also, and also in North India as well. There winding machine companies are already there.
Okay.
They are doing it. Decent amount of winding way they are doing, but that is winding machine is not a simple machine, it's a complex machine.
Yeah.
So it needs its own robotic operations. So
Yeah.
people are capable to do that. Yeah, I cannot tell like 100% suitable as we buy from China. It will be different.
Okay.
India level, they are very good right now. They are growing and they can be used by medium manufacturers as a semi-automatic level wherever we require. We have been buying in earlier companies also. We have been buying locally as well. So
Okay.
the main thing is capability is there. Now they are evolving towards a completely automated way of machines. It may take
Understood.
some time. Yeah.
So you mean for high quality, we still have to then go rely on Chinese machines
In
and
automation, I can tell 100% automation kind of things. We still need to rely there.
Okay.
Maybe people are doing in India. I may be wrong as well, because I still didn't came across them.
Yeah.
Maybe as we go, we can know.
Understood. So what all machines are required in developing an electric motor?
See, generally the basic standard way is like we need a winding machine.
Okay.
We need to have insulation kind of, different kinds of insulations will be there. Sometimes insulation insertion machine will be needed, or we need to have the insulation will be over molded across the lamination. Then over mold machine is needed. It depends upon application again. We cannot be so specific here. But then winding machine, I just told you.
Right.
After that, then soldering, automatic soldering or manual soldering system should be there, or laser welding should be there for connecting the wires. Then rotor side, again, magnets insertion machine should be there.
Okay.
So then gluing machine is one more machine, like automatic gluing. So, and then we need to make it like, keep it in oven for some time. That conveyor is needed.
Okay.
After coming out, final assembly is needed. Then testing dynamometers is needed.
Right.
This is one complete line as a whole I'm talking. After making this, again, we need to have investment on testing as well, because not only motor dynamometer, we still need to have multiple other environmental tests are needed, vibration tests are needed. So right now in India ecosystem, we have those all right now. Yeah. But maybe it will take some more time if I go to somebody else and do. We can also have some level of testing from our side as well. Our intention is to do that as well, so that whatever motor we manufacture, we will be testing as a samples and ensure that 70% of the critical tests are done. 30% I will go out for ARIA or GARC or somewhere, and I can do from them. That is how it is.
Right. So there is this German research group who has developed axial flux reluctance synchronous motor, and that is exactly what similarly you are also doing that, they have developed, like, forget rare earth metals, rare earth magnets, they are not using magnets altogether.
Okay.
So how is that possible, and what's the physics behind it?
See, axial flux as such is a completely different topology compared to existing.
Okay.
Whatever we are doing is a rotational, like, what is the radial flux. So from
Okay.
center, the magnet lines will emanate out.
Okay.
Axial flux means that will be like this, stator, rotor. Okay.
Okay.
So what we say, for example, our existing rotating motors will be like this. So radial and rotor will be radial. Flux will go from center to out. Axial is like, this is stator, this is rotor. So what happening is here is the magnetic lines will be like the travel of the magnetic lines will much shorter than the radial. So that will have its own advantage in terms of power density.
Right.
So I need not go in such a detail here because it will be like confusing things. But overall advantage, what I can tell is they will have high power density because of this complete configuration altogether. And now they are not using magnets, they are telling. So we need to understand what they are doing for the rotor and all. We need to understand. But as such, configuration wise, it is always helpful to make it better power density compared to equivalent radial flux motor.
So in axial flux, what is the degree of freedom? Like where does the rotation happens?
Like the motor is here, stator is here, rotor is here. The rotor start rotating.
Okay.
But flux will be like here, Flux will be like going like this. That's why we are telling axial.
Right.
Okay.
Understood.
Shaft parallel to the shaft.
Understood. So, but what is a reluctance motor? Like we'll slowly build up about coming to the system. But what is a reluctance motor?
See, it's like there are two kinds of torques generally will be there. One is magnetic torque and reluctance torque. Okay. So basically, what is reluctance means the air gap between stator and rotor. I'm talking about radial flux only.
Radial flux. Yeah.
So gap between stator and rotor, if you have that gap, should be uniform to have lesser reluctance.
Okay.
If there is a difference in the reluctance coming, means if the rotor is having different configuration where you have variable air gap, you will have a different reluctances.
Right.
Complete reluctance.
Right.
So there is advantage also, there is disadvantage also. So advantage, the reluctance motor is taking the reluctance as advantage by adding that particular torque as well into the system. Okay, magnets also will be there if magnets are being used. Plus reluctance torque also will be there. So magnetic torque and reluctance torque, both will be added together as two components, giving us the better torque.
Okay.
And making it equivalent to the other motors.
Understood. But then in that case, you also have to then figure out how to manage the cogging torque as well, because that will also change.
Yes, that is also correct. How to manage the cogging torque as well. That depends again how you design the rotor configuration. So you need to you cannot make completely smooth to reduce the reluctance. So you have to have one point between both. You should say.
Right. And what is a synchronous motor?
They are conventional motors. Okay. What they do is they will be synchronous with the rotating magnetic field.
Okay.
And it will run according to that. It will be synchronous with the rotating magnetic field. So whatever synchronous speed we are running, the rotor also will run accordingly.
Understood. So, but is there a asynchronous motor also then?
Yes, that is induction motor. So it will not match. It will have some slip will be there, which is making it asynchronous. So that slip is giving the torque advantage there. So that's okay. You can utilize anything in any way in making a motor better. Synchronous motor also is there. It has its own advantages.
Right.
Induction motor also there, which is asynchronous. Still you have advantages. Coming back to BLTC, have advantages. Also disadvantages as well. Then came to PMSM, also advantages, also disadvantages.
Right.
That is how it is. What is that you want for that application, you need to decide on.
Understood. And what is a permanent magnet then? Like, are they talking about those stones or the minerals that are natural magnets, or what is exactly the permanent?
We are talking about natural magnets.
Okay.
It's like, there are some magnets like neodymium is there.
Yeah.
Like, they will have some two types, like, rare earth and non-rare earth, right?
Okay.
Non-rare earth, right now the focus are going on that. Rare earth magnets will have two more components, like for example, dysprosium, some name will be there. So those things, what they will do, they will add to the thermal characteristics of the magnet. So it will help to the magnet thermal characteristics to push higher side.
Okay.
So which will help us to use our magnet for higher temperatures. So that is the advantage with rare earth magnets, what we are talking about.
Okay.
Okay. It is basically alloy again. It will be individual components will be there. Materials will be there. Be completely processing will be done. Then alloy will be made, and then they will be doing required shapes also will be done. Then that will be cut down. Then they will be machined, and then it will be surface thin surface or zinc.
Yeah.
Like that we will do it based upon the requirements.
Right.
So that is the difference. What I'm saying, like that particular material is being controlled right now from China, which is making it like we need to the thermal characteristics are getting reduced right now. So I cannot go beyond. For example, earlier I am able to go with 120 degrees in the motor. Now I am able to go only 100 degrees. So what it's happening here with me, I am limiting myself the complete performance for not to go beyond the temperature. That is what is happening. So these are the magnet material what we are talking about.
So can you give examples of permanent magnets?
NdFeB, neodymium iron boron is one, and samarium cobalt is there.
So that is not a rare earth magnet, neodymium ferrite boron.
That is a magnet, but when we use this dysprosium, that particular material, then it will become rare earth, which is pushing at higher side. Okay, which will help us in a better way. Or if you don't add that, then that will be non-rare earth magnet.
Understood. So permanent magnets include that neodymium ferrite boron.
Yes, it will be there.
Then again we need then also China is the dominating power, because you need the processing and refining of neodymium itself. That is itself is a challenge. So again, so how is a permanent magnet assisted motor, synchronous motor, kind of giving India leverage?
That is the point here. Now what we are developing is we are working on ferrite. Okay, we are not talking about neodymium iron boron also.
Okay.
Even though that is available without dysprosium as well.
Okay.
And then that will be getting choked because even that raw material also not available in India, right?
Understood.
So we are focusing on ferrite magnet, and ferrite will be kept as a rotor in the rotor, which is a permanent magnet assist.
Right.
Plus the reluctance torque also will be helpful because our design is accordingly.
Understood. So your topology will be such that your power output or the torque output would be equivalent to a normal rare earth Chinese equivalent.
Yes, that is how we are doing the design, and we are expecting it will work on that. Yeah, right now prototyping is undergoing, so I can give better details.
Yeah, sure. So what all losses happen in electric motor? Like we can say there is back EMF, there is eddy currents. So what all sort of losses are there, and if you can describe these two words, back EMF and the eddy currents?
Back EMF. So back EMF, there are permanent magnets are there in the rotor.
Yeah.
Right? So when the rotor is being running, at that point of time, what happens is winding is already there on the other side. So due to the electromagnetic laws, the voltage will be generated onto the stator side, and that voltage should be going to controller.
Okay.
And then should go back to battery as well.
Okay.
So that whole system is taking that. That is the way it works. Okay. So that is the back EMF what we are talking about.
Right.
Second point, what is the other point?
Eddy currents.
Eddy currents. Eddy currents is the what we say they are iron losses basically. So within the stator lamination.
Okay.
That depends upon the thickness. If we are using a bigger thickness of the lamination, you will have more eddy currents.
Okay.
If you have a lesser thickness, then you will have lesser eddy current. So that is the advantage, because the path of eddy current should be shorter to have lesser loss. If I am using thinner one, for example, in existing magnet motors, we use 0.5 mm as the lamination thickness. After there will be insulation. Again, one more lamination will come.
Yeah.
Why should we do that? Why can't we do completely as a block?
Right.
If I do as a block, if it is 100 mm one, eddy current will flow 100 mm. Right? So which is making it more losses.
So what exactly is the loss over here?
Loss is nothing but heat.
Okay.
Finally, it will be heat, because eddy current actually will oppose the complete system. It will oppose the complete system and it will go out as a heat. So that opposing is nothing but because of the Lenz law, right?
Okay.
The basic Lenz law, which we never read when we are studying. So those all will come into picture and create this much very high impact. If I say, if for 100 kilowatt motor, that will be very useful, very, very, huge impact will be there. For example, I'm just telling you.
Right. So like similar to back EMF, the eddy currents are not just contributing to heat, but they are also countering the torque that is being generated in
Not
the.
counting the torque, it will be adding to the thermal growth.
Okay.
Consequently, it will impact all other parameters.
Understood.
Consequently, like whatever thermal impacts will be there, all will be impacted. Even the magnet side also. Like magnet
Understood.
temperature also increases, then you will have a torque impact will be there. Okay, speed impact will be there. Sometimes magnet will be completely demagnetized because of one level of temperature.
Understood.
That is not only because of eddy currents, one of the components.
Understood. So eddy currents are basically heating it up, and that is making the iron lose the magnetism, and that is a
magnets lose the magnetism after one level of time.
Okay.
And of course, iron also will have the magnet. That is only temporary magnetism. You will not have permanent.
Yeah.
When you have a magnet, it will have magnetism. When you take it out, it will not.
Right.
So I'm talking here about permanent magnets capabilities. You are going to limit it there, because if eddy currents are not there, you will have some temperature. If eddy currents are there, you will have some more temperature. So the possibility of hitting the higher temperature is more.
Right. Understood.
That is how it is.
And are there other losses as well apart from eddy currents and back EMF?
There are multiple other losses as well. Copper losses are there, for example. So stator side copper losses will be there. Even eddy current
due
losses.
to the vibrations, copper losses, like what
copper
exactly?
Losses is the current, basically I square R losses. Like current will flow through the copper. So when current is flowing through the copper, then there will be the resistance will be there in the copper, which is giving some losses there also. It is inevitable, right? So that also will go as a heat again. Okay, and magnet side also the heat comes out only. So this all will come out, and then that complete inside the motor, the temperature will be it's concentrating on a particular point, which are known as hot spots.
Understood. And that can also break the insulation of the copper wires, and that can lead to short circuits.
Right, exactly.
Understood. So we talked about the software. Is China also leading in the microcontrollers as well, in these controllers for these softwares? Because for these software, like software is there, maybe you can design a software in India, but again you have to rely on semiconductors, which is again back to China. So are the controllers also then being dominated by China?
Not fully. That is distributed all over. Like we have Japanese one, we have Taiwanese one. Taiwan is very good at that, so there is advantage there. China is having their own product line for it. There's not we cannot deny that, but still there are options there. Even German companies are there, US companies are there. So that is not getting with a single one. I'm not sure the down the line value chain of that one, how it is, I'm not sure. Maybe again that is controlled by China, I'm not sure. Yeah, but as a manufacturing side, there is know-how in multiple countries, right?
Understood.
In India also started now, right? Fab technology has been started, right?
Yeah. So we are developing and focusing a lot on EVs, and we want to manufacture EVs. We want to push electric vehicles, both two-wheelers and four-wheelers, out there in the Indian roads. So if we saw what happened with Ola Electric. So because you can't just ship EVs and don't have the support network, which you also were talking about, and we can't expect, or we shouldn't expect actually, for the companies to have their in-house service centers spread across the country and so forth. Because like for example in combustion engines, you have garage mechanics who are like independent freelance entrepreneurs and solopreneurs, small garages they operate. Roadside mechanics are there. So we need that ecosystem to actually support the EVs as well, because you can't expect either Energy or Ola Electric or similar companies to have their own service centers so much in volume.
I 100% agree that. That is what I always fight on the LinkedIn as well, my side. That is very important. And recently when I went to my hometown also, I saw one Ather service station there. I was so happy to see that, right? So that is missing another side. There are some other companies as well, as you just told right now. But now they are also, everybody know, like after burning the fingers, now started back where they're improving their side improvements in terms of service stations. But they cannot be sufficient for as we grow, right? Yeah. So that need to be decentralized. That is what my point as well. It need to be decentralized. It need to be what we say, the roadside garages, they should be trained for basic level of, at least basic level of repair, opening the motor. Even puncture also people will not do nowadays if they say like it is EV, because valid point, they are worried. I don't know, anything happens, they will be caught on that. But
Yeah.
that level, at least basic level, usual mechanic shops around should be able to train. Maybe that ecosystem has to grow by OEMs only. They only should support on that. They should work on that. That is what I really push for that as
Right.
a EV person.
Yeah, and similarly for the charging stations, because we are setting up charging stations and we claim that electric vehicles are cleaner, that's the whole end game, right? That electric vehicles run on electricity, and the long term goal is that we won't rely on fossil fuels and we'll kind of dump down the petrol, diesel and petroleum and so forth.
Correct.
But right now the charging stations, the electricity that is coming in these charging stations are also coming from fossil fuels. So
Yeah.
how you see that, and what that speaks about the larger EV or the climate industry in India, or even the world for that matter?
Yeah. So it's correct only. It's a valid point, and it's a bigger debate. Like, are EVs really greener is the question. Every time there's a big question. In terms of multiple things, not only power, lithium, mining, everything comes into picture, right?
Yeah.
But the question again comes, why are we not talking about steel mining? Why are we not? Again, nobody is talking about that, because that we
Yeah.
are used to now. So that depends upon narration what we talk about, right? The valid point, what your point is very much valid. Today's condition is we still not 100% green.
Yeah.
What I feel personally, today's condition is, if I buy a ice engine, I will be polluting all through its life. If I buy EV, at least after buying, I'm not polluting. But of course, I'm charging. So I need to say some better condition only I can tell.
Yeah.
For full 100%, we cannot tell like it is perfect, right? That is how today's condition. Then again, other thing is, we also need to increase our capacity as well sooner or later, because as EVs are growing, our EV capacity should be much more now. Otherwise, it will be tough to manage the demand and supply things. Right? So that is how I feel like this is what my thoughts on this.
Great. So yeah, thank you so much, Murali. I want that listening to this, builders or the audience who is actually watching these episodes, and they kind of get to know how exactly what they need to learn, what are the things that they need to kind of capture and leverage, and then so forth accordingly they can enter similar domains and build their own deep tech firms.
Sure. Thank you so much.